Hello guys, welcome back to all. So today in this video I would like to explain about carbon and its compounds. So here carbon, we all know very well about it. So one of the element in the periodic table. But why we are studying about this single element? Because the single element which plays a vital role, it deals with the number of compounds. So basing on this carbon, there is a separate branch in the chemistry. So that is nothing but organic chemistry. Such a very vital important element, this carbon. So nowadays in our daily life also we are depending upon the carbon, because see what we have eat, the food we eat, it contains carbon, or the clothes we wear, and the same time we are using different types of articles, cosmetics, all those things, there is just carbon. And we are using the fuels to run automobiles, so that fuel also containing carbon. So without carbon, in other words, we can say we can't survive, because in every aspect we are depending upon the carbon compounds, right? So it is discovered in the prehistory, and it is known to the ancient times, because we know charcoal. So charcoal is used in the ancient times also. By burning charcoal we get organic material. So charcoal is used from the ancient times. We know the carbon is a non-metal. It belongs to the fourth year group element or 14th group element, and the atomic number of the carbon is 6, and its configuration is 1s2, 2s2, 2p2. So in the outermost shell it contains 4 electrons. So that is why the valency of carbon is 6, 4. So this is all about the carbon. See, it is a non-metal. So the carbon valency 4 and its electronegativity is 2.5. So carbon's valency is 4. To get the octet configuration, there are two possibilities: by losing electron or by gaining electron. If the carbon loses 2 electrons, it becomes C plus 4 cation. If it gained 4 electrons, it becomes C minus 4 anion. But the two possibles are more difficult. Why? Because see, if the carbon's electronegativity is 2.5 and its nucleus has only 6 protons, therefore it would be difficult for a nucleus with 6 protons to hold 10 electrons. Hence the carbon atom may not form C minus 4 ions, because the carbon never gains the 4 electrons from outside, because if it gains the 4 electrons, it contains 6 protons. So it is not possible. By gaining 4 electrons, the carbon may not exist as a C minus 4 form because of its electronegativity. In the same way, the carbon may not form as a C plus 4 ion, because if the carbon is losing 4 electrons from its outermost shell to form C plus ions, so to lose the 4 electrons and to become the C plus ion, it requires huge amount of energy, so which is not available normally. Therefore the C plus formation also is a remote possibility, because the carbon valency is 4, but it may not form as bonds with C minus ions and C plus 4 ions, because the carbon may not form as a cation and anion. Then how the carbon will participate in the bond formation means by sharing. By sharing only the carbon may involve in the bond formation, which means we can easily say that the carbon may not form the ionic bond, but it can easily form the covalent bonds because of the sharing of electrons. So this is the introduction of the carbon. Now let us see how many types of bonds can form the carbon. So now the carbon's valency is 4, but it is difficult to form C plus ion and C minus ion. The both possibilities are not possible, but it can form covalent bond by sharing electrons, right? So the possibility of bond formation by a carbon atom as follows. So there are some rules. What is the first rule? Carbon can form 4 single covalent bonds with atoms of the same element. For example, take CH4, methane, or CCl4. So in both cases, carbon can form 4 single covalent bonds with the same element, right? If you see CCl4, here also carbon can form 4 single covalent bonds with the same atom. So this is the first rule. First rule means it is the first possibility. And now let us see the second one. Carbon can form 4 bonds with different atoms. For example, C, chlorine, hydrogen, and bond. So carbon can form 4 different bonds with the different elements. And carbon can form many form of bond, which means carbon can form single bond, double bond, and triple bond also in some cases. For example, C double bond C and having single bonds with the hydrogen atoms. So this is called C2H4. And also carbon can form a single bond and triple bond. For example, C triple bond C and forming bonds with the 2 hydrogen atoms, C2H2, like this. Which means the carbon can form number of types of bonds, which means it can form single bond, double bond, triple bond, and it can form the 4 bonds with the similar atom and with different atoms. It can form number of types of bonds with number of elements. So here, how it is possible? Let us see. See, if you see the carbon's atomic number is 6, it contains 1s2, 2s2, 2p2. So in the outermost shell it contains 4 electrons. But if you see here, it contains 2s2, 2p2. There are no unpaired electrons, right? Yes, of course, in 2p2 there are 2 unpaired electrons, 2px1, so 2py1, 2pz0. So if you observe here, carbon can having only 2 unpaired electrons in the outermost shell, but carbon can form 4 bonds at a time. How it possible? See, in the chemical bonding topic, there is a famous theory that is called valency bond theory. Already it is discussed in the topic. So in the valency bond theory, there is a possibility of the 4 unpaired electrons in a carbon atom as shown by suggesting the excited state carbon, which means in 2p2 orbital, in p orbital there are only 2 unpaired electrons. In 2pz0 there are no electrons. So here this is called ground state configuration, right? But when the electron from the 2s orbital is excited to 2p orbital, then its configuration becomes 1s2, 2s1, 2px1, 2py1 and 2pz1. See, if you observe here, in the outermost shell now 1, 2, 3, 4. There are 4 unpaired electrons. In the ground state, when you observe here, only 2 electrons are unpaired. But when we are observing here, there are 4 unpaired electrons. So by using these 4 unpaired electrons, the carbon can form 4 bonds with the different atoms. So this is called ground state configuration, and this is called excited state configuration of carbon. So now let us see about some examples how the carbon bonds will form with the other elements. Before going to see that, see here we discussed that carbon can be in excited state. Here one electron from 2s orbital is excited to 2p2. Already we discussed. How the electron will be excited from ground state to excited state? We have to understand that the carbon atom would not be excited in the state under normal conditions. See, if the carbon atom is there, if you observe here, the carbon atom is here. Its configuration is 1s2, 2s2, 2p2. Is it excited in the normal condition? No, it cannot be excited. When the atom is ready to form bonds with the other atoms, the energy required for excitation is taken up from the bond energies, which means it will get some energy externally, which are liberated energies when bonds are formed between the carbon and other atoms. Which means when the carbon atom is ready to form bonds with the other atoms, so it requires excitation. So for the excitation of electron, it requires some energy. The energy is liberated from the other atom, then there will be the possibility of excitation. Is it clear? So by using that energy, the electron from the 2s orbital is excited to 2p orbital. Then the configuration becomes like this. So now we will discuss about CH4. So we all know about methane molecule, how the molecule will form, how the carbon will form 4 bonds with the hydrogen atoms. So here in case of the methane, carbon can form 4 bonds, 4 covalent bonds, and all the bonds having the similar energy, right? But here the bond angle also explained 109 degree 28 minutes. How it can form 4 bonds and how the all bonds are having the equal strength, let us see. So formation of methane molecule, CH4 means methane, we know that. So how the methane molecule will form, let us see. So carbon excited state electronic configuration of carbon is 1s2, 2s1, 2px1, 2py1 and 2pz1, which means 1s orbital, 3 p orbitals will participate in the bond formation, because in the outermost shell it contains 4 electrons. The 4 electrons will form covalent bonds with the 4 hydrogen molecules of s orbital, right? So hydrogen having only 1s1 electron. See, if the carbon atom having 4 electrons and forming bonds with the 4 hydrogen molecules like this, and for 4 covalent bonds, we know it very well. So here my question is, here 4 covalent bonds are forming and all the bonds are having similar strength. But here all the electrons from the carbon atom in the excited state are not same. See, because here one s orbital is there and 3 p orbitals are there. Both the s orbital and p orbitals not having equal energy, because of course the 2s and 2p orbitals will present in the same main shell, but the shape of their orbitals are different. S orbital having spherical shape, whereas p orbital having dumbbell shape. Then how all are having the equal energy? Is it possible? So to explain this concept, there is a hybridization is there. Already we discussed about this hybridization in the chemical bonding topic. This hybridization concept is proposed by the scientist called Linus Pauling in the year of 1931. So it is the great concept to explain different types of molecules, how the identical bonds will be there in the molecules. So Linus Pauling is a great scientist and he got 2 times Nobel Prize. Of course, he is a great humanist also. So now we have to discuss about what is the hybridization. I think we all of you know very well what is the hybridization. Once again I will recall. So hybridization means we know very well the concept, the redistribution or reshuffling of orbitals of almost equal energy in individual atoms to give equal number of new orbitals with identical properties like energy and shape. So it is called hybridization. So in case of carbon atom, if we are intermixing, so 1s2, 2s1, 2px1, 2py1 and 2pz1. So total number of 4 orbitals are there in the outermost shell. If we intermix the 4 orbitals 2s and 2p, 2y, 2py, 2px and 2pz. So the 2s orbital and 2p orbitals are almost having equal energy. If we are intermixing the 4 orbitals, then reshuffle or redistribution, we get the 4 new hybrid orbitals. And the 4 new hybrid orbitals, we get 4 sp3 hybrid orbitals. Is it okay? Here the 4 sp3 hybrid orbitals having equal shape and energy. If you see here, the 2s orbital and the 3p orbitals are not having equal shape. Because of this, the 4 bonds formed by the carbon atom are non-identical. When we are using this hybridization concept, here we are getting the 4 new hybrid orbitals and those 4 hybrid orbitals are having equal shape and energy. And now the bonds formed by the carbon atom, the 4 bonds are having identical energies, identical shape, strength. Is it clear? Now let us see how the CH4 molecule will form. So this is the carbon atom. So if you see here, this carbon atom having 4 sp3 hybrid orbitals. All are having equal shape and energy and all are having one unpaired electron in each case. And now these 4 hybrid orbitals are intermixing with the 1s1 electron, 1s1 orbital of hydrogen atom. So this is a hydrogen molecule. So here like this, in between the CH4, in CH4 molecule, there are 4 bonds are formed between the carbon and hydrogen, 4 covalent bonds. And the 4 are called sigma bonds because these are end-on end overlapping will take place. So that's why here the 4 sigma bonds are formed between the sp3 hybrid orbital of the carbon atom and s orbital of the hydrogen atom, and all are having equal strength and making at an angle of 109 degree 28 minute and having the structure tetrahedron. So this is the formation of methane molecule, because here the 4 orbitals of an atom in the outermost shell orient along the four corners of the tetrahedron to have minimum repulsion, because all are here bond pairs only. Because of this bond pairs there is a repulsion is very minimum, so that is why it can making an angle 109 degree 28 minutes. So here it can this is the structure of the methane molecule. It is making an angle with 109 degree 28 minutes. So this is the formation of the methane molecule, and here all these bonds are all equal energy. So this is the formation of methane molecule. Now let us see one more example. So now let us see the sp2 hybridization. So take the ethane molecule, or the other name is ethylene. See, already the sp2 hybridization is discussed in case of chemical bonding, but now again discussing in case of the carbon compounds, right? So ethylene formula is C2H4. C2H4 means there exists double bond between the two carbon atoms and forming 4 single covalent bonds with the 4 hydrogen atoms. So how it will form? Let us see in case of ethylene. So generally we know the carbon will undergo sp3 hybridization in case of methane, but here in this case the carbon will undergo sp2 hybridization. How it will go undergo sp2 hybridization? Let us see. So we know that 1s2, 2s1, 2px1, 2py1 and 2pz1, right? So but here in this case only the 2s and 2px and 2py orbitals will intermix. So 2s plus 2px plus 2py. So totally we get sp2 hybridization. Then what about the 2pz orbitals? So here in this case the 2pz orbitals remains unhybridized. It means it doesn't undergo hybridization. It remains unhybridized on both the carbon atoms. So only the two carbon atoms will undergo sp2 hybridization by intermixing 2s and 2px and 2py. So here total number of 3 new sp2 hybrid orbitals will form in both the carbon atoms. So the first carbon will get 3 sp2 hybrid new orbitals, and the second carbon will get also 3 sp2 hybrid orbitals, and all the hybrid orbitals having equal energy and equal shape. So now how it will form? Let us see. So the first take the first carbon atom. It will having 1, 2 and 3. So the first carbon atom will having 1. Here the first carbon atom, this is second carbon atom. Each carbon atom will contain 3 sp3 hybrid orbitals. In each case, just wait. And all are having with single electron, unpaired electron. When these two hybrid orbitals separated around the nucleus at an angle of 120 degree, which means here the bond angle is 120 degree. So when the first carbon atom is ready to form bonds with the other carbon atom, which means when the two carbon atoms comes close together, then there exists a bond formation. Let us see. See, if you see here, this is the first carbon atom and this is the second carbon atom. Each carbon atom having 3 sp2 hybrid orbitals, in each case having one unpaired electron, right? And it is also having 3 sp2 hybrid orbitals, and in each case having one unpaired electron, right? And all the orbitals having equal energy. So here in between the two carbon atoms are separated by the at an angle of 120 degree around the nucleus. So when these two carbon atoms comes close together, which means when the first carbon atom is ready to form bonds with the other carbon atom, then the one sp2 hybrid orbital of the first carbon atom is overlapping with the second sp2 hybrid orbital of the second carbon atom. So here in between the sp2 there exists a sigma bond between the sp2 hybrid orbitals of the two carbon atoms, right? And the remaining two sp2 hybrid orbitals will forming the bonds with the s orbital of the hydrogen atom. So like this. So this is hydrogen atom's s orbital. So like this, here the 4 sigma bonds will form between the sp2 hybrid orbitals of the carbon atom and s orbital of the hydrogen atom. So like this, there exists a single bond between the carbon atom and forming 4 single covalent bonds with the 4 hydrogen molecule atoms. So now here already we discussed that each carbon atom, the 2pz orbitals remains unhybridized, which means it is not involving in the hybridization. So each carbon atom having one 2pz unhybridized orbital. So this is the 2pz unhybridized orbital. If these two hybridized orbitals, unhybridized 2pz orbital will overlap laterally, then there exists a pi bond. So like this, in between the two carbon atom there exists a double bond. So like this, the C2H4 molecule will exist. In C2H4 molecule, the bond angle between the carbon is 120 and it is a planar structure. So in between the two carbon atoms there exists a double bond, one single bond and one pi bond. The pi bond is due to the unhybridized 2pz orbital. Is it clear? So like this, the C2H4 molecule will form. So here there are 4 sigma bonds are formed. The 4 sigma bonds are formed by the sp2 hybrid orbitals of the carbon atom and s orbital of the hydrogen atom. Here the single bond is formed between the two carbon atoms, so that is sp2 sigma bond, and the other one is pi bond, and that is 2pz in between 2pz. So like this the C2H4 molecule will form. So the common name for ethene is ethylene. So in ethylene the carbon atom will exist sp2 hybridization. So now let us see what is the sp hybridization. How the sp hybridization will take place. So sp hybridization means, here if you take the carbon atom, carbon will undergo sp3 hybridization in methane molecule, right? Carbon will undergo sp2 hybridization in ethene molecule C2H4, and now carbon will undergo sp hybridization in case of C2H2 molecule. How the sp hybridization will take place? See, in case of methane molecule, in the carbon atom 4 orbitals will hybridize and get sp3 hybridization. But in case of C2H4, only 3 orbitals will undergo hybridization. One remains unhybridized. So that is why here sp2 hybridization will take place. Now in case of C2H4, in between the two carbon atoms there exists a triple bond. Triple bond means only one s orbital, one p orbital undergo hybridization, and the remaining two p orbitals will remain as a unhybridized. So now let us see how the sp hybridization takes place, or how the triple bond will take place in case of C2H2. So C2H2, the common name C triple bond, C and single bond with hydrogen. So this is called acetylene or ethine. So here in this case the carbon will exist 1s2, 2s1, 2px1, 2py1 and 2pz1, right? So but here only one 2s orbital and only one 2p orbital will undergo hybridization and get 2sp new hybrid orbitals. The both carbon atoms will undergo sp hybridization, which means here the 2py and 2pz orbitals are remained as unhybridized, which means they are not participate in the hybridization. So each carbon will undergo sp hybridization and each carbon atom will get 2sp new hybrid orbitals. See here, this is the first carbon atom. It is having 2sp new hybrid orbitals. And this is the second carbon atom. It is also having 2sp new hybrid orbitals. So when here the two carbon atoms comes close together, then there is a overlapping takes place between the first carbon atom's sp orbital with the second carbon atom's sp orbital. So here the overlapping will takes place in between the two carbon atoms sp orbital and sigma bond will form. So like this, the sigma bond is formed between the sp-sp hybrid orbital of the both carbon atoms. And the remaining sp orbitals are overlapping with the hydrogen atoms s orbitals and form sigma bond in each case. So like this, there exist two sigma bonds between the sp hybrid orbital of carbon atoms and s orbital of the hydrogen atom. Is it clear? So now we have to remember one point here. In each case, there will be two orbitals remains unhybridized. So let us draw the hybrid orbital. So this is the 2py orbital of first carbon atom and this is the 2py orbital of the second carbon atom. Now let us draw one more orbital. So this is the 2pz orbital, this is the 2pz orbital. So already we discussed this 2py and 2pz remains unhybridized, right? When these two are overlap laterally, which means the 2py overlap laterally, there exists a pi bond between the 2py. In the same way, the 2pz overlap laterally, there exists a pi bond. So another pi bond will be formed between the 2pz and 2pz. So which means in the carbon atom there exists triple bond, which means one sigma bond and two pi bonds. The one sigma bond is between the two sp hybrid orbitals of the two carbon atoms and the two pi bonds are between the 2py and 2pz orbitals of the carbon atom. So like this, in the molecule acetylene there exists a triple bond and having single covalent bonds with the two hydrogen atoms. So like this, the ethene or acetylene molecule will form. In the acetylene molecule, the carbon atom will undergo sp hybridization. And all are having equal energy and shape. So this is today's class.